There are lots of videos on social media showing this amazing spinning wine glass trick, where you can turn the wine glass upside down without the wine falling out. So I thought I'd make a video to explain the physics of it. To get it to work, you need to add a small amount of wine, or I used squash, to the glass, and then I find it easiest to spin it up to speed using one finger at the base. Once it's spinning at a good speed, you can turn it upside down and the wine won't come out. However, if you leave it upside down for too long, then you'll notice that as the wine glass slows down, the wine works its way down to the bottom of the glass and it comes out making a bit of a mess, although it is rather pretty. To understand the physics of what's going on, let's consider a slightly simpler problem where we replace the wine with a small polystyrene ball. Once again, when we turn it upside down, the ball doesn't fall out and just goes round in a circle at the same speed as the glass. Let's pause the video and draw a force diagram or free body diagram to work out what's going on. And I think there are three forces which are acting on the polystyrene ball. To keep the diagram simple, I'm going to draw all the forces acting from the centre of the ball, even though they won't all actually act at that point. So first of all, we have the weight force, which is acting down. Then we have the normal contact force of the glass on the ball, which will be acting at 90 degrees to the wall of the glass. Finally, we have the friction force, which will be stopping the ball sliding down the glass. If we add all of these forces together as vectors, which involves putting them tip to tail, we can then draw a vector arrow from the very beginning to the very end, which will give us the resultant force. As you can see, this resultant force acts towards the centre of the circle that the ball is going round, and it provides a so-called centripetal force, which keeps the ball moving round in a circle. To get a step closer to explaining the liquid in the glass, I tried putting a large number of cumin seeds in, as they're all small separate particles. We can see that they go round much as the ball did, and we can see that they're travelling at the same speed as the glass, i.e. there is no relative motion between the glass and seeds. Of course, the big difference with the liquid is it can flow, and that the different parts of the liquid can exert forces on each other. If you watch carefully as I turn it upside down, you can see that there are various interesting flows going on in the liquid. But once it's upside down, it looks to me like there is a thin layer of liquid which is stationary relative to the surface of the glass and just goes round with the glass like the particles did. You can see that particularly clearly in this clip. Now let's return to the ball in the glass to understand what happens as the glass slows down. You can see that the ball slides slowly down the glass before finally falling out at the bottom. On the left, I've got the force diagram when it was moving round in a stable circle. And on the right, I'm going to adapt the force diagram to show what happens as the ball slows down. The one force that doesn't change is the weight force. When the ball is travelling slower, it applies less force to the side of the glass, which in turn pushes back with a smaller normal contact force on the ball because of Newton's third law. That in turn means that the friction force is also going to be smaller. Once again, let's arrange those forces tip to tail to add them as vectors to find the resultant force. Now we can see that the resultant force is pointing slightly downwards. The component of that resultant force towards the centre of the circle does keep the ball moving in a circle, but the component of that resultant force down causes the ball to accelerate down. However, because the glass gets narrower, as the ball moves down, the radius of the circle gets smaller, which in turn increases the centripetal force required to make it go in a circle, and therefore it becomes stable again, which is why it takes a long time to slide out of the bottom of the glass. Returning to liquid in the glass again for one last time, we can see clearly that we have a thin layer of liquid going round the glass at the same speed as the surface of the glass. And gradually the liquid works its way down until it reaches the bottom, and then it flies off at a tangent to the rim of the glass and then into a lovely parabolic motion as it becomes a projectile. Anyway, I hope you've enjoyed this video and understand a little bit more about how the spinning wine glass trick works.